Welcome to the Roboticist Chronicles, an ARC Specialties podcast, where we get into the nuts and bolts of robots, automation, and the implications of an evolving machine workforce.
Hello, I'm Dan Allford, and you're listening to the Roboticist Chronicles. We have some friends in from out of town, and we coaxed them into the podcast studio because they work in a fascinating industry, and I wanted to get them to talk about plasma cutting, and gouging. So Greg and Soumya, please give me your full names.
Gregory Culp.
Soumya, Mitra.
And what do you do for a living?
I am a robotic lead manager at Hypertherm, and basically I get to meet fascinating people like yourself around North America selling plasma.
I work at Hypertherm as a technical director of integrated cutting solutions, and I get to work on fun applications and talk about solving challenging problems with potentially by using plasma cutting.
And so if we go way back to when I started ARC Specialties in 1983, one of my first jobs was a hot tap at a plutonium plant, and without plasma, we couldn't have done it. We had to cut through stainless steel. You can't do that with oxyacetylene, so way back in 83, we did a plasma cutting job and then gas tungsten arc welding, and so I've always been a fan of the process. It's an enabling technology in a whole lot of applications, and it allows you to do things you can't do with oxyacetylene, you can't do with laser. It's just another technology. It works out very well. And Hypertherm is a unique company. I consider you guys to be probably the undisputed leader in an industry, which is remarkable. I haven't seen that in any other industry in the world. You're too humble to admit that, but you know what I'm saying.
Thank you. Yes, I think we invest a lot of our revenue back into the engineering and technology wing, and so we have tried to come up with newer technology that has solved real customer problems. And I think over time we want to do more of that and grow the company, grow where plasma can be used, and grow with our partners.
Well, the history of plasma, as I understand, is that once upon a time NASA needed to test the ablative coatings that they put on reentry vehicles. Then as they're flying in through the atmosphere, they're heating up, and in order to simulate those high temperatures, they were using plasma. And then a certain group of fellows decided they could use it for industrial applications. Am I close?
Yes.
Yes. I think that was surely one application where plasma was used to test different materials and figure out what to use. Within Hypertherm, Hypertherm started in 1966 by our founder, Dick Couch, and he really got the attention from the industry when he solved the cutting problem with the water injection patent that he had and the product, the PAC 500 and thereon. And it is still a very legendary product out there. There are still people using it. And so he used water to constrict the arc and then used that constricted arc to cut material faster than any other technology back then. And so we still try to hold on to that pathos of Hypertherm on winning on technology, winning because we have the best products and technology out there.
Interesting. So, and you've evolved quite a bit. You're now, every country I go to, I see Hypertherm equipment.
Yes, Hypertherm is worldwide. I think it's over 56 countries, but could be mistaken there. But yes, we have representation all around the world.
And I think we have also grown from like mechanized cutting to handheld products. We just launched the PowerMax 33 this week. And so we continuously come up with newer products in different segments. So handheld, automated, CNC, robotics. And I think Hypertherm has grown beyond plasma now as well. And so, and I'm speaking for my colleagues in maybe Washington. So they have the water jet, which is part of the Hypertherm Associates umbrella as well.
So let's talk about plasma. Fourth state of matter, right? There's, let's see, gas, solid, liquid, and plasma. And you constrict the arc within a nozzle, and then it's that constricted, focused arc that gives us the energy that allows us to cut or gouge. And so, I'm agnostic on cutting processes. We use everything from carbide inserts to oxy-fuel to plasma. So when do you pick plasma? I know you guys want to use it everywhere, but
I would love to say that you can use plasma everywhere, but potentially to cut material, you can go from like a scissor, very thin
Chainsaw.
to chainsaws to using plasma and oxy-fuel water jet. I do feel so. Metal cutting is plasma. Where we use plasma plus. In very thin material like in HVAC industry ducting, we have a different plasma system because the needs of that industry is different, and so you can cut gauge materials. We're talking millimeters to 6.25-inch stainless steel for oil rigs, right? And so you can do all of that. I would definitely say that there are segments of that industry in metal cutting where lasers are good, and there are customers who should go buy a laser if they need it. And then there are segments where oxy-fuel might be the right tool if you're cutting really, really thick.
Over 6 inch.
And in some cases. And you probably have a lot of experience doing.
Oh, we've cut 36.
Right. And so there are definitely applications where plasma is the best tool, but there are applications where it's not.
Well, I'll tell you where I use it. It's if you have anything other than steel, because steel is unique in that it's exothermic, and so when you cut it with oxyacetylene, that's how you can cut the thick stuff. But aluminums, stainless, other materials like that, you have to use plasma, or in thinner cases, I suppose, laser. But that's where I draw the line. Is if you're going to do. If you want high-speed cutting, because what are the speeds you're cutting this sheet metal? It's just outrageous.
Right, and so that's a really good point. And so we were initially constrained by how fast the cutting tables were, and those cutting tables have evolved over time. And so
to keep up with you guys,
we made the cutting systems to work with 80 to 100 inches per minute kind of cuts with maximum maybe like 250 inches per minute cut speeds. We were able to push that envelope, and maybe last year we came up with the high speed processes, which can push the envelope to about 1,000 inches per minute. And it is a great product for like HVAC ducting industry. And so we do like to evolve with time, and so that is an example of us trying to push that envelope or staying with the advancements that happen in our network.
Yeah, you guys are always pushing the envelope one way or another. So you came down here to talk about a new initiative you have.
Yeah, we have several new applications that we're focused on. We talked about gouging. We now have XPR gouging.
Well, that's another example of where plasma will do something nothing else can do. We can do a partial depth cut with plasma, and there's really no other process that can do that except possibly milling. It's a process I love. It's something we've been building since the 90s. I've got plasma gougers that have operated in the jungles of Bolivia. Nothing against the jungles of Bolivia, but I'm just saying it's well out of the laboratory and into industrial production. So yeah, gouging and cutting.
Yeah, we've had gouging on our Power Max and Max Pro systems for years, but last year we introduced XPR high definition gouging, and we're seeing really good results from that. We're also focused on other applications like post-table bevel, being able to have one cut bevel machine all right in front of you. And then we're also focused on shipbuilding, and a lot of the shipbuilding systems that are out there, cast trimming, cutting aluminum. We've made some really good strides with that. And then we're introducing, which will be coming out pretty soon, is our EPA, which is Extended Pilot Arc.
Something I've been asking for years. Thank you very much.
Soumya, you can talk more technical about the Extended Pilot Arc, but it's a really unique feature, and it will give a lot, what I'll say, especially in shipyards and steel processing of beams, they will benefit greatly with the XPR system on this.
I'll get back to that. What do you define high definition as? What kind of tolerances can people look for with plasma?
Sure.
You said high definition. What's that mean?
That's a great question. And what we have tried, the way we have defined it in the past is, if we can keep that edge square, and in ISO terms there are ranges, and so if we can keep it in range 2 and 3, we call that as high definition, and so we're talking like 20,000s, less than 20,000s kind of tolerance top to bottom on that edge, and so on like half inch kind of.
So half a millimeter. That's pretty good.
Right, right. And so that's the kind of tolerances we're talking about for high definition. And then not all products need that. And so we do have products that have high definition torches on them, and then we have products that don't. And to talk maybe more on the gouging application, for example, right? And we heard from our customers that their pain points about carbon arc gouging and how much noise it creates, and the challenges that they have with the manual processes, and they desperately wanted to automate gouging, and that's where we brought the gouging to the XPR series, or the more the system that has the more power, which is really good for some of our key customer segments like shipbuilding, heavy industries, and the automation part is not something Hypertherm does. It's like partners like you who have been able to bring it. And last year we heard about the zero force machining. I'm curious, what was the motivation behind that?
Well, we call it zero force machining, and what that does is eliminate the need for fixturing. And so if we're doing plasma gouging, plasma cutting, then we can simply lay a part on a table. We don't have to fixture it, don't have to clamp it. And if you have zero tool force, unlike milling and turning and such as that, then you eliminate the need for all the fixtures.
Right.
What it does is it means that we have to do a lot of adaptive control. We have to find the part, we have to follow the part, but that's our job. But there's a lot of applications for zero force machining. Even if you're willing to fixture the part, you don't want to distort it with tool force.
Right.
And by doing it, with your technology, with gouging and cutting, all of a sudden you don't distort the part. So there's a lot of applications. We need our audience to start thinking about where they might use that.
Right. And it is very interesting because when we pitch gouging as a solution for carbon arc gouging, where people are using that for weld prep, and it is a great tool to solve some of their weld prep related challenges. We have heard people bring us to other application like casting, gate removal, where they are currently using like a manual carbon arc gouge, and somebody in that hot afternoon inside a shed is doing that carbon arc gouging. They want to automate that process, and carbon arc is not really great for automation. And so what you started with zero force machining is a great solution for that industry, where somebody is manually still using the carbon arc gouge.
Yeah, here's a little bit of yestertech again. I actually automated carbon arc gouging way back with an advanced robotics robot. They're defunct now. That's how far back it was. And it was a fun process. And for two reasons. One, it was the only way to remove metal quickly. We're able to cut a 2-inch groove in 2 passes, which, there's no other technology. It was zero force machining.
Right.
But the main reason we were doing this is way back in early robot times where we didn't have good adaptive control. The robot couldn't find and follow the groove. But if the robot, we use the same robot, cut and welded the groove, all of a sudden we didn't need vision systems, through the arc tracking, and that still has application. The other system we collaborated on, we call it BatBot, that holds onto the bottom of a ship or a tank and cuts the hole and then re-welds it. We're leveraging the fact that the robot cut the hole with a Hypertherm plasma unit, and therefore we don't need vision systems through the arc, etc.
Right.
So there's some of that.
Right.
There's a lot of advantages to having the robot cut the groove, because you can't make a good weld unless you have a decent groove.
Right.
And that's what we're hearing a lot. And I think you touched upon it exactly, is for better welding, you need better cutting.
Mm-hmm.
And that is exactly a great example for that. Right?
I've solved welding problems at the cutting with cutting systems, and then we ended up not even needing to automate the welding.
Right.
And there's a lot of folks in this world, like myself, that I like welding, and I want to be a welder. But have you ever met anyone that wanted to be a carbon arc gouger? It's a miserable process. And so yeah, and that's when we started doing plasma gouging in the I guess in the 90s. It was such a relief to get rid of those carbon electrodes and
Right.
all the noise and smoke and fumes. Right. Plus, there's people that are concerned about carbon pickup in the plate with carbon arc. So the only alternative is what you guys have, which is plasma gouging. I hope to automate a bunch of that. We just got to get we got to get our audience to embrace this technology. But trust me, if it works in the jungles of Bolivia in the 90s, it'll work in your factory today.
Agreed.
So. What's next? What are you guys working on? Got any conferences coming up? I know y'all did one last year, right?
Yeah, so we are targeting industries, and we are trying to align industries and applications, and we are trying to answer a couple of questions around why is plasma an interesting technology or technology to look for in that industry. And so we would love to talk to like shipbuilding folks, and we've done something with that particular industry in the past. We would love to do some heavy industries, castings. We do a lot of work with American Foundry Society, Steel Foundry Society, and so we would like to understand their problems and maybe come up with a solution with them. So maybe we can use our current products. If our current products don't work, then we would like to innovate and bring a different product to the market. But we solve the problems with integrators such as yours, right? Who can then bring the solutions to the customers.
And you missed EVs.
Yes,
yes. That was one of our success stories
yes,
during
absolutely.
COVID.
Yes,
We built 13 plasma cutting systems for the EV industry. So, literally every industry benefits from your technology.
and I think that no contact trimming or cutting, I think, was the key for the castings industries to adopt plasma, because you're not putting forces on it. You don't have to worry about having the part being a little bit off from the CAD, which is almost never the case. I mean, yeah, it is going to happen. In the CAD, it almost is always like a flat plate, but in reality, it's like a potato chip, right? And so you do need technologies which is forgiving and works with the realities. And so plasma really took off in that industry because it can accommodate those dimensional variations. And along with the vision technology that's out there and adaptive robotic programming, that industry just started adopting more and more plasma.
We actually get feedback from your torches too, because if we know the arc voltage, then we can infer the distance between the robot and the part. And so that gives us our final bit of real-time adaptive control. We can follow the contour in real time.
Right. And again, in that industry wanted some like changes in how we did it in the past. And for example, we used to have these 5-piece stack up. And so you're individually looking at what electrode do I use, what nozzle do I use, what swirling do I use, when do I change it. And so these decisions were at the operators, and the automotive industries with those high volume production, they wanted to go away from it. So we were in the right place with the right technology with the cartridge, where a single piece cartridge was able to solve their problems. And we did have the RFID technology in there, which counted the number of starts, the life of the tool. And so they could take the decisions. The operator then could take the decision when to change the parts and when to change the tip and how to use the tools that they have.
Right, and we capitalized on that on the system we built. It's operating in the UK, cutting heavy steel parts for earth-moving equipment. But and that's the problem with all tools. At some point, they wear out. If it's a physical cutter, they get dull. If it's a plasma torch, they start to erode and degrade, and you can estimate when that change needs to occur and simplify the task of changing it, which is going to be useful. We're starting to do some stuff with the small modular reactor guys, so doing nukes, and so you can imagine in that environment, they want a very simple, automatable way to change consumables.
Right. That's the nice thing about, I mean, you can automate it, that you can have a tool changer for the cartridge now.
Outstanding.
Yeah.
That's an essential part, particularly if it's going to be a radioactive environment. So we need to talk more.
We're here.
We're good. It's been a great relationship over all these years. I had so much fun visiting your plant maybe 10 years ago. You guys are pushing the envelope on everything, constantly engaged, always looking for new things to solve. And we're the same way on a much smaller level. But I think it's a wonderful relationship because I want a tool at the end of the robot arm, but I don't want to develop it. That's your job.
Right. Yes, and we want to hear about all the pain points you have. But I would tell you this: what we see in your shop is really nice, with a lot of camera and I think you said this really right. Is we have to make the life easy for the operator.
We're trying to have zero programming.
Right.
I think that's the key. So I think what you're working on is what we are hearing from our customers is how do we solve, how do we make it easy for the operator to make decisions, take actions, and let the system do its job.
Our goal is for our customers to never touch a teach pendant on a robot, and the latest project we're talking about, I feel pretty good that we might be able to accomplish this. It'll change the world.
Yeah, I would say is we think about the end user and making it easy for them, but also at Hypertherm, we're thinking about our partners and applying tools that'll make your integration and your life easier so that it's not a complicated process to put those tools in place. So it's not only just an end user that we're thinking about, we're also thinking, how can I provide the equipment to you so that you can integrate this easily?
We deeply appreciate that. It was way back in the 90s that we needed that long arc length.
Right.
And initially your systems didn't have the open circuit voltage, and now you do. So you are responsive to our needs, and we deeply appreciate that.
Thank you for bringing us the challenges.
Well, it's been fun, guys, and I know you got to catch a plane, but what else is new? What else did you want to talk about today?
I would say we love, just like you, to hear about the challenges that our customers have, and so one of the things that like Hypertherm launched really in the last couple of months is extended pilot arc, which was the case with the smaller systems where you could start off the cutting plate, and then as you moved into the plate, the arc would transfer and start making those cuts.
And that's huge for roboticists because that means we can miss the part
Right.
and still make the cut.
Right. And so that I think that is a key for a lot of robotic customers because they don't have to now spend a lot of money or time on finding that edge. They can program a path, and as long as the part is in that envelope, it's going to make that cut. And so the robustness of that system goes up. And again, it makes it simpler for the operator to do what they're supposed to do. And so I think I'm really excited about having that technology, but I'm really happy that you now have a tool which you can use for various different applications.
We were talking about it. You're also going to give me feedback from your controller. By the way, I like your interface. And we'll get feedback that will indicate when we've initiated the arc. So potentially we could change parameters.
You can respond to it. Yes, absolutely.
I think that'd be pretty cool. Yes. So we got to get one of those systems down here.
Absolutely.
We'll make it happen.
Well, very good, guys. Well, I appreciate you coming on today, and also I really appreciate all the years of cooperation. It's been very beneficial to ARC Specialties, and thanks for being here.
Thank you. We appreciate everything that you do for Hypertherm.
Very good. We'll have you on again.
Thank you.